Hi all, good morning. Welcome to my next video. Today I'm going to discuss about the topic column chromatography. From the name it is clear that this is one of the chromatographic technique. We know what you mean by chromatography. Chromatography is a technique which is for the identification, separation and purification of components. So one of the method or one of the technique involved in chromatography is column chromatography. So today in this video let us discuss it in detail. So first of all, the main application, whatever be the chromatographic techniques, the first point should be it is used for separation, purification and identification of both solids and liquid. The second point about this column chromatography is this is a solid liquid chromatography, which means the first thing solid means the stationary phase is a solid, which means there is a non-movable part of the component, that is a stable component, and the stationary phase, that is a solid, and liquid is the mobile phase. So actually there is a solid is be there is a solid phase is be there, that is it should be a stationary phase, and we are passing a liquid through that is known as column chromatography. So we know that here the stationary phase is solid, then the mobile phase is liquid. Then we can see that the separation of the components in the mixture will be happen on the basis of adsorption ability of a component in the mixture. Which means, so the separation of the component is mainly due to the difference in adsorption coefficient. So we can see that this is an example for adsorption chromatography. Usually, so let us discuss what you mean by stationary phase. We know that there's a stationary phase is this not movable part. It is mainly silica, alumina, calcium carbonate, calcium phosphate, etc. Because we know that all these are inert solids. And second one is mobile phase, and mobile phase should be a liquid, and it's like a suitable solvent like hexane, ethyl acetate, dichloromethane, etc. That's about that. Then we are passing the components and the solvents through this stationary phase. Then there should be a need or the necessity of the separation of components, which means there should be a separation is being needed, and that separation is based on the activity of adsorption, and the polarity of the solvents depends the extent of separation, which means if good activity and low polarity gives good absorption. If a solvent has low polarity and a good activity, then we can say that it will provide good separation. Let us discuss that. Then first of all, let us discuss how can you conduct a column chromatography experiment. Actually this is a column. You are familiar that this is it's similar like a burette. It's like this is a long tube, and at the bottom part you can see that there is a small part which is closed by something cotton or a wool. കാരണം അതിൻ്റെ മുകളിലേക്കായിട്ട് തന്നെ സാധനങ്ങൾ താഴേക്ക് വരാതിരിക്കാൻ. First of all, you have to just put a piece of a cotton or a wool at the bottom of the column, and the tube itself is known as column. And the above of that wool or this cotton, you have to fill the stationary phase. I am representing this is the stationary phase. But you have to keep it in mind that when you fill the stationary phase, or whatever be the components or the solid substance which is used as the stationary phase during the packing of this column, or during this you put this things or the solid things in the column, there should not be any holes is present, because if any holes are be present, then the component may struck on that process, or they may occupy on that empty spaces. So first keep it in our mind that the column should be tightly packed. Once again, first of all, you have to take a long tube, that long column. At the bottom, you have to fix just a small piece of cotton or wool. About that, we are pack the stationary phase in tight manner by avoiding holes or pores. Next of all, we are going to add the mixer into that. There are two possibilities. In the previous slide I discussed that this technique is also used for the separation of both solid and liquid. So if the component is liquid, then it is easy. We have to pour it into the above of the stationary phase. If the solid is the component to be separated or purified, shall we put this in here? No, because solid cannot be penetrated through this. If the components to be separated is a liquid, first of all, you have to dissolve that component in a suitable solvent. Most probably, it is the mobile phase. Then we get a liquid. Then you have to add that component into the top of the column. That is the second process. Then next of all, we have to add some amount of mobile phase through that. When this mobile phase is the liquid, so it can penetrate through the solid surface. When the penetration will be happen, also the components are be penetrating along with the mobile phase, or we can see that the mobile phase bring or it's pull the components into down. But we know that the components are having different adsorption coefficient, which means they have difference in adsorption ability. You can see that this is one component, this is the second component, this is the third component. You can see that this component is highly adsorbed to the solid surface, and the second yellow is less adsorbed than this, and this component is the least adsorbed component. These all the components are present in this mixture. By the passing of this mobile phase through this, the components get separated due to the difference in adsorption chromatography or adsorption coefficient. Then you have to take, then we are pouring this, when you pouring this or when you pass the mobile phase through this components get penetrated, and we have to collect the components in separate beakers. Once again, I am explaining the process. First of all, you have to take a column which is plugged at the bottom by using a cotton or a glass wool that we discussed here. Next, the stationary phase, silica or alumina is mainly processed, is packed in a cylindrical column that we know. Then mixer to be separated is dissolved in suitable solvent and introduced at the top of the column and is allowed to pass through the column. That is the picture number 2. Next is the components are adsorbed at different regions, depends upon the ability of adsorption that I explained. The components with greater adsorption coefficient will be adsorbed at the top and other will be at the bottom. Then അപ്പോൾ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ താഴേക്ക് വരുമ്പോൾ ആദ്യം സെപ്പറേറ്റ് ചെയ്യുന്ന കമ്പോണൻറ്റിൻ്റെ പ്രത്യേകത എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇറ്റ് ഹാസ് ലെസ് എബിലിറ്റി ഫോർ adsorption, and the components which is exist at the top having high adsorption ability. Different components are desorbed using suitable solvents called eluents, and this process is known as elution. എന്ന് പറയുമ്പോൾ നമ്മളൊരു കമ്പോണൻ്റ് ഒഴിച്ച് കഴിയുമ്പോൾ എന്ത് പറ്റും, ഈ അഡ്സോർബ് ചെയ്തിരിക്കുന്ന സാധനങ്ങൾ വീണ്ടും ഡീസോർബ് ചെയ്യും. അതിനുവേണ്ടി നമ്മൾ യൂസ് ചെയ്യുന്ന കെമിക്കലിനെ വിളിക്കുന്ന പേരാണ് എല്യുവൻസ്. നോർമലി അതെന്തായിരിക്കാം, നോർമലി ദ കമ്പോണൻസ് ആർ മെയിൻലി mobile phase. If strong adsorption ഒക്കെ ആണെങ്കിൽ we are using another solvents. അപ്പോൾ അങ്ങനെ യൂസ് ചെയ്യുന്ന കമ്പോണൻസിനെ വിളിക്കുന്ന പേരാണ് എലുവൻസ്. Weakly adsorbed components will be eluted first and followed by others. Different fractions are collected separately, that we know. Then let us discuss the applications. The first application that is now, it is used for separation, purification and identification of components present in the mixture, that we know. It is also used to separate organic components plant materials, because the plant materials or plant components എന്ന് പറയുമ്പോൾ നമുക്കൊരു പ്ലാന്റിൻ്റെ എക്സ്ട്രാക്റ്റ് കിട്ടിക്കഴിഞ്ഞാൽ ഇറ്റ്സ് കൺസിസ്റ്റ് ഓഫ് എ നമ്പർ ഓഫ് components or materials or proteins like that we can use the separation for this technique. It is also used to separate desirable compounds after organic synthesis. It is separate or purify natural compounds like alkaloids, glycerols, etc. That's about today's section. Have a nice day. Thank you.